Okay, so we're starting to record it. And so this is EE3563, and this is the first class meeting. So most of you know me because you took logic design. Is there anybody in the class that's never had me as an instructor before? Just, you can say something. So everybody kind of knows who I am, so I'm not going to spend any time on that. So this class is pretty much my passion. I really do enjoy it. So hopefully you will too. You will do well in this class if you come to laboratories and do the labs. Make sure you demo all the labs. You can only miss one lab and still get a grade in the course. And you also have to do the final project. So if you do the final project and all the labs, save one, or hopefully all the labs, then you'll definitely get a grade in the course, and you'll probably get at least a B. It's really rare to get anything less than that if you do all the work, because the projects in the lab are 50% of the course. And we don't really, I grade a little bit on the projects. About the worst grade I give on the projects is probably an 85, assuming you do something. If you don't do anything, then you get a 0. But even if you make a real good effort, sometimes students bite off more they can chew, and in the end they don't really get it done, and it's kind of frustrating for them. And I hate that, but I still give you credit. Yeah, because typically I know that you've been working on it. I've been helping you and all that. But this semester will be a little different. So I'll talk about that in a minute. So let me first bring up the syllabus. And so I just want to go over that. And I'm going to blow this up a little bit so you can see it really well. Okay, that's good. Okay, let me share my screen and go over the syllabus. Okay, can everybody see that?
Yes, we can see that.
Yes.
Okay,
Yes.
okay, so the way this will work, so this is a 3-1 course. So it has 3 lecture hours per week and 1 hour of lab. Now, you can probably get your lab done almost every week in 1 hour. There might be a week or two where it takes a little more. The way we do the lab, you're all assigned to a lab section on Friday between, I think there's a section at 10 a.m., 11 a.m., 12, 1 p.m., and 2 p.m. And so we run the lab from 10 to 3. You can come in whenever you want. If COVID is still heated up, we'll probably try and limit the number of students in the lab a little bit to maybe, I think if it's really bad, we'll try and limit it to 14. But usually we're a little bit flexible on that. Hopefully Omicron's going to burn out here soon, and we're going to be, COVID's going to be reduced to something more like the flu, and we're going to get back to normality, I hope. But you never know, right? But anyway, come to lab. That's really the message. We are going to try and hook you up so you can do these labs at home. But if you come to lab, there'll be people there that can help you in real time. And believe me, that's nice. When you're working on a lab and you're trying to write your code and it doesn't run, or you're getting compile errors, and you look at the error description and you go, well, what does that mean? If somebody is there that can help you, they can tell you what it means, and it can show you where your problem is in your code and keep you moving. If you're at home, you're going to get frustrated and throw in the towel and quit. And then, when you come back to it, I don't know, a lot of students just give up at that point. And that's not what we want. We want you to push through and learn the material. Programming microprocessors is incredibly frustrating until your code runs. And then when your code runs, it's exhilarating because it's, kind of exciting. It's very cool. And you start to feel really good about yourself. And you can imagine that you can actually do this someday and make a good salary. So this is why it's really important. And there are a few of you that just have, I don't know, the knack to do this on your own. That's fine. but I encourage most of you to come to lab and get the help you need. And if you do that, even if you're struggling, you will find that the people in the lab will, and I'll be there a good part of the time, will get you through the lab and keep things moving along. So come to lab. And if you do that, you're going to do well in the course. So that's what I really encourage. Okay, let's see. So the prereq for this is logic design. There is not a textbook, but we do use the data sheets for the PIC 16F1829. And then, oh, I haven't, I didn't put this in. So we also, this semester, we are going to talk a little bit about the so it's also microchip. So yeah, so that's good. So we do have a new board, and we'll probably charge $15 for the board and the snap programmer. That's at least what I'm thinking about right now. I don't know, maybe I'll make it $10 or 12 or something. We will also provide you with an analog board with a 2x16 LCD display, and with a CP2102 USB to TTL UART dongle that plugs into your board. And actually in the new board, it plugs in one of two different locations. So what we've done is we've added onto the standard PIC board, we've added a ATmega 328 PB processor. And what this does, it allows you to run both processors at the same time. They talk to each other up through the I2C line. And the ATmega 328 is basically a supercharged Arduino Uno processor. And with a bootloader installed on it and everything set up, we can actually use this with the Arduino IDE. So if you plug your CP2102 in the top part, you can program your Arduino, and if you plug it in the and then you can program your PIC with the snap programmer using the programmer header for that. And then if you want your PIC to write to the UART, then you can slip your CP2102 in the other plug, and the PIC can write out to the screen. And many of the labs. So the way we're going to do this, this is a little bit of our grand strategy. I think in the future, we're going to actually set these boards up for the incoming freshmen to use in the Intro to Engineering course. And then they'll use the Arduino part. And then when they get a Micro 1, we'll have them solder on the rest of the headers and use the PIC part. And and then we'll do some labs. We'll do labs using the PIC chip, the 16F1829, and then we'll do some labs where we use both chips, and the ATmega inputs some sensor, and then it transmits that information over I2C to the PIC, which then maybe displays it on the on a terminal window, or maybe puts it out to a 2x16 LCD display. So I think you're going to find this will be really fun. I don't know that we're going to do, in the past, we have used the KO25Zs for the last lab or two, but we didn't do that the last couple semesters because it's just, it's a logistics headache to get it done during the COVID stuff. And so we probably won't do that this semester either. In fact, I may just take that completely out, but that's the processor we use in Micro 2. So that's why we sometimes try and introduce it here. Okay, so keep in mind that it's going to be a little different because we have a brand new revision 5 Viva board instead of the revision 4. And I'll show you those right now. Maybe let me I'm gonna, let's see how best to do that. Yeah, I'm gonna, yeah, let me just switch. I'll stop sharing and I'll just switch cameras. That's probably the easiest way to do it. So let me do, oops. Yeah, let me do that. Okay, so this is this was our prototype board that we made, and then this is our current board. So you can see what's, let's see, let me rotate this around so it's going in correctly. So what's kind of different, so this is the PIC chip here, and let me see, can you if you may want to blow that up, let me do, make sure I can see what's going on. How come it's not? Let's see. Okay, well, I'm not sure why that doesn't show up. Yeah, I know it's got a little bit of a glare. The light's built in, but I'll do this. So if we can do this. Yeah, and what I'll do is I'm going to turn the light off. Yeah, and then maybe I'll scoot this down. Yeah, maybe what I'll do is bring up the document.
We can see this better.
Yeah, I think it's not too bad. I actually have a picture of it. Let me just do that. Let's see, that is here. I think it's in should be right here. Oh, let's see, where did I put it? Okay, so yeah, all right. All right, so let me share my screen and I'll show you that. Okay. All right, can you see this now? So here is the, so basically, here's the AT Mega 328, and here's the PIC. And we have a header here for the little plug-in UART, and the header here for the PIC USB to UART dongle, and here for the AT to USB UART dongle. And we'll have a battery input here. I didn't solder on yet. That's a reset switch for the 328 AT Mega, and this is the reset for the PIC. And then here's a push button. We used to combine these and have a jumper for them, but now we just put both switches. We have an RGB LED here called Hello World, and then we have headers here where all the pins from the PIC come out, so you can connect to any of the pins on the PIC. It has 20 pins, and the AT Mega has 32 pins. Some of the pins of the AT Mega are brought out on this header, some on this header, and then there's an analog header 1, 2, 3. They're brought out here, and then here's the I2C header that's connected to both the PIC and the AT Mega, and then here's a little prototyping area, and yeah. So and then here's some analog pins brought out from the PIC that your analog board will plug into directly. Here's the programming header for the snap. And then these are touch pads connected to the PIC. And of course, the RGB LED is connected. And then there is one LED here connected to the AT Mega. And then there's one LED here that tells you when power is applied. This is a jumper that allows you to power it from your USB to a UART dongle, regardless of which one it's plugged into. And you can jumper it for 5 volts or 3.3, or you can plug in a battery here. And this is a 3.3 converter that will power it that way as well, but only for 3.3. So if you want to do 5 volts, you have to use the USB connection. Anyway, so that's what it looks like. So the boards, when we get them all made, and we're going to be making them we'll be making them this Saturday. So, and let's see, I'll switch my camera back. Oops, there we go. So when we make the boards, this Thursday afternoon, starting about 3:30, I have maybe 3 students signed up or so. So I did send that out in the email. If anybody else wants to come over, there's probably room for maybe 6, 7, 8, 10 students. So maybe 7 more that might want to come. We'll be making these boards. Of course, we start with a blank board, and all the surface mount parts we will first stencil on the solder paste, and then we'll use the pick and place machine. It will automatically place the parts on the board, and then we'll put the boards in the reflow oven and bake them. And that will then cause all the parts sitting on solder paste to be soldered. And then then what we'll do on, hopefully we'll have 90 of them made on Thursday, and then we'll be able to have students get them on Friday. And I may charge, like, I don't know. It's kind of progress. What's that? Go ahead. Did you say something, Sarah?
Oh, no, sorry. I just logged in.
Oh, okay. So anyway, we'll have those available, and then there'll be all the through hole parts. So you can see all the plastic headers and the push buttons and the battery plug. All those things will have to be added on. Now, initially, I'm just going to have you add on the stuff associated with the pick. So it'll be less soldering to start with. And then once we get through maybe a few labs with the pick, we'll do a lab where we include the AT Mega 328. And we'll get that, we'll solder on some additional parts. There was one mistake we made in the schematic, and we left off a capacitor that's needed to be used with the Arduino IDE. And so we'll give you one of those caps and some little wires, and you can solder that on as well. And that'll allow it to be used with the Arduino IDE. So anyway, so we'll get that done. All right, so let me go back, and I want to talk about, we'll go through the rest of the syllabus here, and we'll talk a little bit about this. And so here we go. So I'm going to share the screen again, and we'll do the syllabus. Okay, so I'm not sure just how much to charge. I'll try and figure out, because my goal is not to make a profit or anything. We just want to cover some of the costs. But so the Snap programmers, we get those from Microchip. If you just buy one, they're like $25 or something like that. But we get them at a big discount. And then the Viva board, probably our cost on the board, I don't know, it's maybe a dollar something for the printed circuit board, and both of the processors are a little over $1. And then we probably have another $4 or $5, maybe $3 in parts or something. So it's something like, it's probably about $6 or $7. So between the two of them, I think if we sell them for about maybe 10 or 12, maybe $12, it'll probably be good. Maybe as much as 15. But anyway, so have say $12 to $15 in your hand on Friday, and then hopefully we'll give you the pick board, or the new Viva board with both these chips on it, all the surface mount parts on it, and then we'll give you a little bag of the through hole parts you have to solder on. And then that's what we'll do this week is get our board soldered up. And then next week, we'll hopefully get started with lab 1 on Friday. So you'll have basically from Friday to get them soldered up. We will have solder stations set up on Friday, but you can solder them at home, or we'll try and have solder stations set up in the makerspace available most of the week. So you can just come in and solder them anytime you want. And it probably won't be crowded at all the first week. So that should be a good, safe way to do it. I don't know. I don't have cases made for the Viva board yet. I'm still figuring out just how I want to do that. I may instead design little plugs to plug it in the corners and support it that way. I don't know, but we do have cases for the snap, and I guess I need to print out some more of those. So we'll eventually get those all printed out and available. And then we'll also give you a micro USB cable that works with the snap. Then later on, we'll have everybody sign out the TTL to UART USB interface, the 2102, the CP2102 dongle, and then the analog header and the 2x16 LCD display with a little interface board on it. So we'll basically provide those. I think I have enough, although I didn't get as many back last semester as I wanted. These I'd like you to turn back in, but the snap, the Viva board, the snap programmer, you get a keep, and the cable. All right. So we're gonna basically talk in a fairly general sense about microcontrollers and how most of them work. We'll learn in detail about the PIC, and we'll also learn some detail about the ATmega 328. They're a little bit different, similar but different. They're both 8-bit microcontrollers. You're going to write some programs and do some labs. In the labs, a lot of the code is given to you, and you just have to modify it a little bit. But then you will have to do your own final project, and for that you will have to write your own code. You'll be able to use some of the code you used in your labs. So when you do your labs, make sure that your lab code is nice and clean, and that you document what you did and you save it. So you have all those files available on your laptop or on a jump drive, so you can use them when you do your project. You can borrow code, and then for a number of things, there's code provided on Blackboard for interfacing various things. And then, of course, in this particular case, with the addition of the ATmega chip, you'll be able to use the Arduino IDE and the code that's pre-done for practically every sensor that's ever been developed at the hobby level, anyway. And so that really is going to expand dramatically the things that you can do on your project. But you will be required to use the PIC chip for certain parts of the project, so you actually have to write some software. We're going to cover how to use peripheral modules. We're going to cover how to use your integrated development environment. And so the main IDE we'll use will be the MPLAB X for the PIC chip. They are slowly modifying MPLAB X so it could program the Arduino too, but I don't know if it's gotten quite to that point yet. So we'll probably use the Arduino IDE, which is a whole lot easier to use for the ATmega 328. You can also use Microchip Studio, which used to be Atmel Studio, and program it that way. But usually in that one, you actually need a programmer debugger that attaches to the ISP header, and we're not gonna do that. We're gonna use the Arduino IDE instead, that uses a bootloader. All right, so we're gonna talk about some of the features of the IDE, like how you use debugging features. Those are not available in the Arduino IDE, but they are available in MPLAB X and Microchip Studio. So that's one of the reasons why we don't use the Arduino IDE for everything, because it doesn't teach you some of the things you really need to learn. So we'll talk about embedded processors. The first few labs we will use the PIC assembly language to do, which is different than the Atmel assembly language. So we're not going to really mess with the Atmel assembly language. We'll maybe talk about it just briefly. But we will learn how to use the PIC 16 assembly language. And the reason for this is that if you learn how to program a microprocessor, any microprocessor in assembly language, it pretty well gives you insight into how all of them sort of work, even though their instruction sets are different. The way in which they work is very similar. And if you learn one, it really gives you insight into how to learn any of them. In addition to that, remember that when you write programs in C, which we will do after about lab 4, all the rest of the labs will be in C. When you write in C, the compiler immediately changes your code into assembly language. So when you're actually trying to debug it at a deep level, if you don't know assembly language, you're kind of dead in the water. So it is helpful to see, and you can, when you look at the C code, you can see exactly how it was compiled into assembly, and you can follow along in the assembler. So we will learn the programmer's model. We'll see how the chip is set up with its various registers and whatnot, and how it actually works. I think this is also important. This really distinguishes a computer engineer from a computer scientist. A computer engineer knows how the machine works at the basic hardware level. Computer scientists don't really worry about that so much. We'll talk a little bit about some different addressing modes, how parameters are passed, and we'll talk a lot about the C language. We'll kind of do some review, even though you've had some, and hopefully a number of you took Bob Apollone's course and you got some actual skill in C. We'll look at how the chip is organized, how its memory is organized, how its peripheral structures are organized, and then we'll learn some of the basic principles of how we interface things to the microprocessor, maybe if we have an external chip we want to use. And we'll also learn how two microprocessors can talk to each other. All right. And so we'll have homeworks, quizzes, a midterm exam, a final project. I should say midterm exams. We'll actually have a programming exam, a practicum, and a midterm written. So there'll be at least 3 midterm exams. So there may be 1 or 2 quizzes for maybe a couple of points each, or maybe we won't do a quiz. We'll see. There'll be a final project, which is 20 points. The labs, 25 points. So that's almost half the course right there. Then homework will count 12 points. There'll be 8 homeworks. There'll be 3 midterms. Again, a programming test, a practicum, and a written one. I guess we'll do the programming, written one, and then the practicum after that. And then a final exam that's worth 22 points. So that makes up the 100. So I'll just do letter grades, A, B, C, D, E, or A, B, C, D, F, no E's. But you might get an incomplete if you don't do all the labs, or you might just get an F. We'll talk about that. I usually let students have an incomplete if they want, if they've done most of the other work and they're just missing, a few labs. Last semester, there were quite a few students that didn't do all the labs, and it was really a crisis at the end of the course. And this semester, that's not going to happen. We're going to track it a lot more carefully, and we're going to make sure you're well aware how many labs you're missing, and we're going to make sure that you have ample opportunity to get them done. All the labs are there's one due date for all the labs, but I do not at all encourage you to wait till the last minute. We'll go through that in the schedule, but there's one day where all the labs have to be turned in. Make sure you stay well ahead. What you should do is try and get all the labs for each week. You should try and get them done that week. And if you don't, then get them done the next week for sure. And then make sure you try and get the lab for that week done too, if you can. Try not to get behind. Some students did not even start on the labs till halfway into the course. Just don't let that happen. Get started right away. This week, come to lab, get your parts, solder your board together, and get going on be sure you do the first lab next week. So, all right. If anybody, if the $12 or $15 is a problem for anybody, I will give you the hardware. Don't worry about it. There's, that's not the point. Nobody should be, don't let $15 cause problems for you. Okay. So there's some other important policies here. You should read through these. So make sure you turn your homework in on time. Make sure you, again, all the labs. Let's look at the schedule. So here's the schedule. If we scroll down towards the end, so the 22nd of April will be the last day to turn in labs. That's it. After that, you cannot turn in your labs. So if you realize in the final week, oops, I'm missing 3 labs and I'm going to get an incomplete, too bad. That's just the way it is. We're not going to, we don't have this, just it's just so disruptive to have students coming in and trying to get help to finish up all their labs in those last few days before the end of classes. And it's just not fair to the TA. It's not fair to me. It's not fair to our helper. You have all semester to get these labs done. We will finish the last lab. I think the last lab will be, the last lab will be on the 8th of April. So, and then all you'll be doing, what's that? So anyway, so just make sure you keep up with the labs. And some of these labs are, I think, are really interesting and helpful. I will modify what's currently listed here. I'm sure some of them will be different because we're going to include parts off the Arduino at some point. Or maybe we'll just leave that for your final projects. We'll see. But for sure, we're going to do at least one lab where we have the PIC talk to the Arduino and the Arduino talk to the PIC. We'll do that for sure. All right. So you can see we'll have a lecture Tuesday, a lecture Thursday, and a lab Friday. And that's how the course is going to go. And again, keep up with it, come to lab. All right, I'm going to stop sharing that. All right. So I think that's all I really wanted to go over on that. Okay, I'm probably not going to really start in on the course material. Let me just take some time to let you guys ask some questions and make sure everybody is on the same page. And then Thursday, I will start covering the course material. Go ahead, questions?
Yes, can you hear me?
Yeah.
Hello, Professor. I just have a question about the labs. So I'm supposed to be registered like in the lab that is on Friday at 8 a.m., right? So, but we're gonna start labs next week or this week?
So this week, I want you to come in and pick up your parts.
And it has to do during the lab time. So I can go on Friday at 8 a.m. and I can pick up the parts.
Yeah, so let me see if, I don't know.
I got me confused.
Yeah, so let me see. Let me look at the Zoom. The labs are supposed to start at 10. If they scheduled one at 8, I don't know how that happened. But let me see. Hang on one second. Let me pull up ASAP. I mean, that may very well be the case. It's just disappointing.
Yeah, I have it at 8 a.m. to 8:50 a.m.
Yeah. Okay. So we're not gonna start at 8 a.m.
Oh, okay.
So you can come in anytime between 10 and 3.
Perfect. Okay, so I'll be there at 10 a.m. then.
Yeah,
Sure.
that's fine. And for most of the folks, I encourage you to kind of space yourself out through the 10 a.m. to 3 p.m. time frame. If everybody comes in at 10, it'll be a panic. But you're welcome to come in at 10. But it'd be nice to, if yeah, let me see. Actually, if that's what they did, I guess they did. So.
Also, the lab is in the engineering building, right?
Yes. So the lab is in the engineering. So it's EB, and it's O2. So it's on the second floor. The engineering building has 3 floors, basement. Well, it's 1, 2, and 3. It's on the second floor, and it's in the main hallway. If you come in the end of the door that's closest to the biology building, that's as you walk in that door, it's the first door on your left. And we'll be there at 10 a.m. and we should be there. We'll have somebody there hopefully all from 10 a.m. till 3. I'll be there part of the time. I've got other classes and stuff, so I won't be there the whole time, but I'll be in and out. And we have an undergraduate helper that's going to help, who's very competent, and we'll have a TA that's done this before, who's working on a PhD on Schul. And so she's done it before, so she's kind of dialed in. So we're actually in fairly decent shape.
Okay, and where can I buy the equipment, like the chips and the? And
No,
the
so we'll have it all for you in the lab.
Oh, okay, perfect. I'll be there then. Thank you so much.
Yeah, I mean, assuming
Yeah.
we get them manufactured. So normally I would have done it last week, but I had COVID,
Oh,
and
sorry.
so I couldn't do it, and we couldn't have people over. We were quarantining, so not much you can do. But anyway, but I'll be wearing a mask on Thursday, but well, I'm already 8 days now from the onset of symptoms. So I think I'm totally symptom free. I'm feeling good. Been double vaxxed, boosted, had the native strain back a year ago, and I still got Omicron. Or well, I'm assuming it's Omicron. But anyway, so okay. I was just looking real quick here to see. I think it is actually.
And real quick, Professor,
Sure, go ahead.
what was the C programming based language we were going to use for a course?
So we're gonna cover the assembly language for the it's called the enhanced instruction set for the PIC 16 series. So I'm gonna talk about that in great detail. So, and you're only gonna do that for 4 labs. But again, I want you to learn it because, and we will have you, that you will take a programming test on that. So that will, so you'll need to know it for the programming test. Programming test is fairly low threat. The worst you can get on it, I think, is a 65 or a 70 or something. Even if you miss all the problems, you still get a 70. But if you get them right, then you can get 100 on it. So it's a nice opportunity to get a good score going. And I'm going to go over exactly the questions I'm going to ask. I'm going to cover them in great detail, and you just have to pay attention. And the key to understanding the instruction set is understanding how the chip actually processes instructions and works. And that's one of the reasons why we do it, because I want you to learn that, because that's how you'll understand how these processors do what they do. And if you don't know this, yeah, you can still write C instructions and load them and get things to happen, but it's more like a magic trick than it is engineering. For you to really understand what's going on, you have to learn assembly language. You have to know how the chip works, and that's what makes you different than a CS student who doesn't understand that stuff. They're just working with higher level languages, and they don't really know how the processor does what it does. But you need to know that, because you're the engineers and you're going to use the hardware at the hardware level. You're going to be hooking wires up to your chip and up to other chips and making them talk to each other. And you have to know how they're doing that. You have to know voltage levels. You have to know current requirements and things like that CS students don't know. You're computer and electrical engineers. It's a different world. So we're going to learn it, but we're not going to spend all the time on it. We're going to switch to C and do the rest of the course in C, do your project in C, and everything else will be pretty much in C. But it's amazing the insights you get by learning how to write some assembly language instructions. It forces you to learn how the chip works, and that's the point. Okay, that's the point. I want you to learn how the chip works.
Professor, I have
Go ahead, Matthew.
So it is C, not C+ or C#.
So there's all sorts of limitations that most microprocessors bring to the table, and for that reason, they can implement some features of C++, or C# or whatever, but normally there's some features they don't implement. In the case of the PIC, for instance, you can't nest subroutines. And the reason you can't nest subroutines is it has a hardware stack. It doesn't have a relocatable stack pointer. And so as a result, the stack only has 16 levels. So if you nest a subroutine and you call it, it calls itself more than 16 times, you're going to overflow the stack and the chip gets lost and the program crashes. So there are some features of C++ that you can use, but there are some features you can't use. So it's probably best to think, most of the time when you're using microprocessors, it's probably best just to think in terms of C. Usually the real C++ features that are helpful, I mean, there's some that are nice, but the critical, the ones that are, the big power ones have things like inheritance and things like that. And usually that involves much larger programs than we're going to write for an embedded processor. In the PIC, our program memory is limited to, I guess 8K. And so there's some limits to how big your program can be. And anyway, so yeah, but there are features of C. It does have, yeah, I guess in the PIC, it does. I think the PIC 16 series doesn't let you do C++. But like when we use the KL25Z, you can, in Micro 2, you can use features of C++, but even there, it's really it's kind of a pseudo C++. It's not. You'll find that for most microprocessors, they they haven't really implemented, all the features of C++, even though they kind of act like they have. So it's basically going to be C.
Professor, for the, I have two separate tabs for the microcomputer systems, one for the lab and then one for the actual class. For the lab assignments, is it going to be posted in the lab microcomputer systems? Okay.
We won't use those tabs at all.
Okay. All right. Thank you.
Yeah, no, that's a good question. All right. What else?
For the $15, is that cash or will there be card accepted as well?
No, cash. So bring some ones too. I'll probably make it $12. That's kind of what I'm thinking right now. So if everybody brings $12, that'll work. Go ahead.
We can pay you like Friday, like before the lab and everything, like those.
Yeah,
50, so
yeah. And again, like I said, if somebody doesn't have any money, just don't worry about it. But yeah.
So just to reiterate, Professor, we would bring you the $12 or $15 on Friday when we go pick up our things in the lab, and then we'll be good to go for that.
Right, you'll get the board
for now,
and you'll get the through-hole parts, and then you can start working at soldering them on. Mm-hmm.
Okay, awesome. And then that would be it for like what we would.
That's all we're going to do Friday.
Okay, that's what I thought. Thank you.
All right, any other questions?
Could we change?
Oh, go ahead.
She can go first.
Go ahead,
The
Nani.
syllabus says that the tests are going to be online. Is that accurate?
Yes. All the tests will be online, except I may do the programming test is essentially it's a written test, but I'll have you probably do that online. But the practicum, what we'll do for the practicum, you'll actually come to class. You can be in groups of 1 or 2 students or 3 students, whichever, 1, 2, or 3. You bring your laptop. You have some shell programs all set up, and then I'll give you a specific assignment, which you'll do as in your group of 1, 2, or 3. You can do it by yourself if you want, or with 2 or 3, or with 1 or 2 other people. And you basically have to write a program and program it into your board and demonstrate it working. And as soon as you get that done, if you get that done by the end of class and you fulfill the requirements, everybody will have a different program to write. Every group will have a different program to write, a slightly different, then if you get it working and you get it working correctly, you get 100%. And then we'll have, if you get this done but not that done, then you get 95. And if you don't have that done, you get 90. And if you don't have that done either, you get 85. And there again, there'll be a worst case scenario, something like 65, I think, or something. But anyway, it's again, not a big threat, but it is, the whole idea is to see, if you can write the code under pressure. And I've had some semesters where students really, really struggled. I've had some semesters where everybody got it done amazingly fast. I couldn't believe it. Yeah, last semester it was kind of okay. And, we had a number of students that didn't quite get it done, but a number did. So I don't know, could have been better. So we'll see if we can make it really be great this semester. But yeah, but the rest of them will be online.
For the ones that are going to be online, are they going to be proctored or?
No, you can,
Okay.
you'll have all day to take them anytime you want. They will be
Okay.
randomized, no backup,
Okay.
and
So
you should do the work yourself, but they're open book.
Okay, so if we have like something to do at like a certain time,
No
then
problem.
we don't have to worry about it. Okay, thank you. That's what I was gonna make sure because
You'll have all day from midnight to midnight.
Okay, awesome. That sounds good. Thank you, Professor.
Do you know how many questions?
It varies. I don't remember. I don't know. I think the final had maybe like 80 questions, and I think some of the other tests, the written test had maybe 50. So, and you'll have like a couple hours to do them. I think maybe 3 hours for the final, an hour and a half for the other one.
Are the quizzes
they-
and homework similar?
What's that?
Are the quizzes and homework similar to the exams or no?
Yeah. I mean, it comes out of the lab and out of the lectures. I guarantee you everything on the final, everything on the written test, everything on, well, the programming test, I will go over it in glowing detail. The practicum is going to be kind of a free for all on its own. But so really it's just the written test and the final that'll be, really, a question answer type test. And we will have covered everything in lecture multiple times. So it's really good to come to lecture. It's really good to pay attention. And I have videos when I did it online that you can also, look at. A lot of students went back and looked at videos from the prior semester. But it'll, this board will be a little different. So there'll be some stuff about the ATmega 328 that doesn't appear in any previous years, which I haven't actually done yet. I got to get all that worked out, but we will cover that.
So for the final, will that one also be open book or open note?
Yeah,
Or-
the online test will be everything. In fact, the only test that won't be open notes will be the programming test. I want you to do that from your
Okay.
head. I'll
Um,
give you the instruction set.
Okay.
But but you'll have to write the code. You won't be able to copy from your notes. But all the rest of the tests will be, and even that one actually. I guess that one was open notes last semester, and people still had trouble getting it done. So go figure.
Okay. Are the tests going to be like fairly easy, or what do you?
They'll be easy if you know the material. Yeah,
And
I
if we
mean,
pay attention, basically.
yeah, if you come to
Okay.
class and pay attention, you should be able to get most of the questions right. And obviously, you might need to review, but if you do that, you'll be fine. They're not meant to trick you. I expect everybody to get A's and B's in this course. And the only reason you won't get A's and B's is because you didn't do, you didn't do some of the work. Didn't do the homework. So you got a 0 for that. Missed one of the labs. If you miss more than one lab, then you get an incomplete. Maybe skipped one of the tests or got a really low grade on got the minimum grade. So it's pretty easy to get a good grade in this class. I don't want you to be worrying about grades. I want you to be really enjoying learning how microprocessors and embedded designs can be done, can be used, and getting some level of confidence. And you'll find when you first, if you just buy one of these things and download the instructions, start watching YouTube videos, it's hard. It is hard to do it because there's always something they don't tell you that you needed to know. And when you have somebody to mentor you through it, it's so much better. And that's why this is a good situation. You're going to learn from this, and you're going to come out with a level of confidence. And when you've done it with one microprocessor, it's a whole lot easier to do it with another. All right, what else? Let's see, if we're attending class from home, are we allowed to have someone else pick up the equipment? Yes, you can send somebody else in to pick up the equipment for you. Have them give them your ID and have them do it. But for the love of God, plan on coming to class for the lab. We're not going to do. We're only going to do the labs, the classes online for the first 3 weeks. So I know what happened last semester. There were a bunch of students that didn't get the labs done, and what happened was they didn't come to UTSA for the first 3 weeks at all. Stayed in Houston or Austin or wherever they were, and then when they finally showed up, they were 3 weeks behind. That's a bad plan. Don't plan to do that. Plan to come on to San Antonio, get all set up, and come to lab on Fridays. And if you do that and stay up with the labs, you're going to do fine in the course. I guarantee you, you come to lab every week, you will get a B as a minimum grade. You will not do worse than that. And if you just do a decent job on everything else, you get an A.
Professor, another question. Sorry about that.
That's okay.
This Friday, when we pick up the equipment, we're gonna start the lab already immediately on Friday, or
No, the first lab will be done the next week.
Next week, perfect. So,
yeah. For one thing, I don't know if I'm going to get. I have a lot of snaps already, but I don't have 90, and I'm waiting on microchip to see what's going to happen. So I won't have enough snaps for everybody until next week. I may have to buy a bunch, and that's fine. I'm not going to raise the price to you guys if we do. It'll be fine.
Thank you so much, Professor.
Professor?
Yeah.
So are the labs done independently, or are we having lab partners?
You could, so we don't have formal lab partners. Every individual gets credit individually for their labs, but you absolutely can work together. The only thing I ask is, what we don't want you to do is just well, a lot of the code's going to be provided. You only have to write a little bit for the labs. And so, so don't just, wholesale copy your partner's lab. Just,
okay.
But yeah, we encourage people to work together in lab.
Okay, thank you.
What we want is everybody in lab to use at some point, no matter how you're actually doing it, make sure you type the code in for your board and put it on your board and run it on your board and make sure your board works. And then you demo. And so with a lot of the labs, there's a little quiz to turn in, but that's not what counts. What counts is when you show to the TA that you've got the lab done. That's what counts. That's when you get credit.
So basically
right,
we
good.
can work together with somebody else, but we each have to turn in our own assignment.
You each have to demo it.
Okay.
And if we do let students, if they don't finish in lab, we let them go home and then take a video. You can take a video with your ID card and the video showing your board executing the lab as it's supposed to. So you can take a short video and send that to the TA as well and get credit that way. That's okay. Okay, any other questions?
Yeah, I had a quick question. If we wanted to go help on Thursday, did you want us to come in knowing a couple skills or any experience?
No, you mean no, we'll teach you how to squeegee, solder paste on the boards, and how to drop them in the pick and place machine, and that's pretty much all set up. We just have to hit run basically, and then once we get that done, we'll pop them in the reflow oven, and so I may have I don't know, I haven't loaded the bootloader on all the chips yet. I haven't even started doing that, so we may or may not have to load the bootloaders on afterwards. I'll see. But if I'm hoping to get all the bootloaders loaded on the chips before we solder them onto the board. We'll see. But I may even have some students doing that if we have enough people. So yeah, no, we'll show you. I think, you know, it's usually a pretty fun time. Most people really get into it. There's a little bit of, you know, like squeegeeing the solder paste through the stencil. You know, it takes you have to do it a time or two to feel like, okay, I got it just right. If you get too much paste on it, we have a bunch of bridges on the AT-Mega 328 part because it's fairly fine pitched, and so you have to be stingy with that socket. But the rest of the parts are nothing super critical. So usually it's, you know, we get a pretty high yield. But yeah, and usually before we bake them, we'll maybe adjust a few parts and just make sure they're exactly perfect. But the pick and place machine puts them on, you know, pretty precisely.
Hey,
Awesome.
Professor. I had a question. I don't know if I missed it, but do we know when we're gonna meet on Thursday and like when
my house. So I think yeah, I'll so anybody that wants to come, send me an email, and as long as I think there are 3 people signed up, so there's room for at least 7 more and maybe a few more than that. And then I'll send you back an email and say, great, you know, here's the address. I mean, it's, you know, I don't know if it's on Blackboard or not, but anyway, I'll send it to you. I live in Churchill Estates off Blanco, near Blanco and Bitters. So, and I'll send you the address, and then you can always call my phone too if you get lost. And then I'll have pizza. So we'll start hopefully about 3:30, 4 o'clock. We'll get started, and then we'll probably work till 9 or 9:30, maybe 10. Hopefully we'll have 90 boards done by then. For a few short, I might do some more before now and then. I'll probably run a few more.
So what time do we have to meet up and the address? What time? Sorry.
Yeah, so send me an email and I'll send you an address. So I mean, there's not room for 90 people. I wish there were, because I think all of you would enjoy seeing it. I'll probably take some videos and post them so you can kind of see what we did. But yeah, but if you can come and you want to help, that's great. And you know, if we have 15, that's fine. You know, that'll be okay too. It'll be a little crowded, but we'll figure it out. And then if some people want to come for a few hours and then some people want to come late, that's okay too. So we'll just kind of work through it.
Professor, I sent an email before. You want me to send that email again?
I think I have, so let's see. I think I have, did I reply to your email?
I haven't gotten anything back yet.
Okay, so no, that's okay. If you sent one, it's good.
Okay, thank you.
Okay, cool.
All righty. So good turnout today. I'd like to see everybody again on Thursday. Again, I think you're going to learn a lot. I do encourage you to come to class. You know, it's not that I'm that brilliant, but I you know, I've done this a bunch, and I think you'll find that we'll put out the information that you need, and it took me a lot of semesters to learn how to teach students how to do the assembly language programming. It took a long time, but I think I figured it out, and so it's a lot better in person. So we're going to delay the programming test until we've had some in-person sessions to really go through the programming code. So I'll have to look and see when it's scheduled for, but I think it's past the first 3 weeks. And anyway, but I'll do it on video, and we'll cover a bunch of stuff. And I think you'll find you'll learn some good things. I think a lot of students enjoy this class. That's my goal, to make it fun. And the fun part about it is the hands-on, and when you finally see your little program work. So I'll show you let's see, maybe I'll fire this up and show you the AT-Mega driving the little display. And then we'll maybe finish with that. So let's see, let me share my screen, and or actually let me share my I'll just share my video. Oops. Okay, so I don't know if you all can see. Let's see. All right, so yeah, so you can see. So here I'm just gonna reset so you can see the little Arduino thing here, the little OLED display. Yeah, it's running this little demo. So I have a whole bunch of these, and so hopefully we may get to do this in lab on one of the days. We'll see. And then it goes into the snowfall. I think it goes through all the characters too here in a minute. Yeah, they're the characters. Hard to see. Scrolling. Oh, other way. No. That's right. And then here are the snowflakes, I guess. Yeah. So it's a, it's a cute little display. These things only cost about $2 or something like this. They're pretty cheap. And then we'll also use the 2-line by 16 LCD display. They're fairly inexpensive. So we'll use the touch buttons. We're going to do, we're going to do a bunch of stuff. So, okay. So hopefully you'll learn a lot. All right. Last call for questions.
I already sent you the email. I just wanted to make sure if you got it.
Okay, probably.
Morales.
Yeah, I'll have to actually don't have my email pulled up. I'll check it in just a second.
Yeah.
Yeah, I'm sure. As long as you send it to paul.morton@utsa.edu, it's good.
Yeah.
Just to make sure, there is no book for this class because I saw on the ASAP that there was a required one.
No, I don't know. Sometimes ASAP's a little spastic, but what we use are the data sheets. One of these days I may write a book for this class, but there's not a really great text. There are texts out for for the programming pick parts, but they're just not really focused on. They cover a lot of stuff that's in excess of what we really want to talk about and learn. So I don't know. I've looked at a bunch of them. Anyway, I haven't found one I really like. So, but the data sheet's sufficient, and we'll go through the material and lecture is sufficient. So,
right, thank you.
Mm-hmm. All right, last call. Going once, going twice. Okay, so we will see you for. We'll start with the material on Thursday, and we'll talk about the PIC 16F1829 and its instruction set and how it's the programmer's model and all that. And so hopefully you guys will hopefully we'll get off to a good start. And then on Friday in the afternoon, then we'll have some students over. We'll hopefully manufacture 90 of these suckers, and we'll disperse them to students on Friday. All right, we will see you then.
Thank you, Professor.
All right.
Thank you.
Mm-hmm.
Thank you.
Thank you.
Thank you.
You bet.
Thank you.